Hi, this is Jay with Jantech, and this is Good Stuff to Know. Today we're going to take a really deep dive into the value, benefits, and quite honestly the necessity of having a true make-before-break external maintenance bypass on your UPS system. The benefits of having an external bypass certainly outweigh the cost, in my opinion. So let's start and take a deep dive into this. Going to diagram number 1, we're showing a double throw disconnect. This is probably the least expensive maintenance bypass we've seen over the years. It's a double throw switch that you can put 2 sources into, and the output of that switch is going to feed your critical load. What's the disadvantage to this? It's a break before make. So in the event you have a failure on your UPS, yes, it's a way to reroute power to your critical load, but there will be an interruption in getting over to that secondary source. This next drawing is a 3-breaker maintenance bypass, which is generally used when the customer only has 1 feeder breaker to the UPS system available. The 3 breakers that make up the bypass are BIN, which is the bypass or utility input to the UPS, MIB, which is the output isolation breaker, and MBP, which is the maintenance bypass breaker. On this drawing, we're showing the UPS online supporting the load. So BIN is closed, MIB is closed, and MBP is open. If we want to get over to the maintenance bypass and off the UPS system, it is imperative that we transfer the UPS to internal bypass before we go over to maintenance bypass. The reason for this is, if we were to close MBP right now under this configuration, Ohm's law says power is going to go to the path of least resistance. That means when we close MBP, that utility is going to look 2 places, out to the load or back into the UPS. Unfortunately, most UPSs have a very low output impedance, and chances are that utility power is going to backfeed the UPS and is going to do significant damage to the UPS, and quite honestly will probably trip the feeder breaker to the system, and there will be a loss of critical load. So in this configuration, we must make sure that we transfer the UPS to internal bypass before we attempt to go to maintenance bypass. On the next drawing, we're showing that 3-breaker maintenance bypass configuration running in the maintenance bypass mode. So therefore, BIN, the input, utility input to the UPS, and MIB, the output isolation of the UPS, can both be open, and the maintenance bypass will be supporting the load. On the very next drawing, we're going to show a 3-breaker maintenance bypass with a solenoid key release unit, SKRU, interlock. SKRU Kirk key interlocks are essential, in my opinion, for any maintenance bypass. What does it do for you? It will not allow you to operate the maintenance bypass breaker until such time that the SKRU control unit gets a signal from the UPS that it's in internal bypass. Once you transfer the UPS to internal bypass, it will allow the release of the key or Kirk key lock on the maintenance bypass breaker, then will allow you to close breaker MBP and open breaker MIB, hence placing the load on external maintenance bypass. We're going to talk about SKRUs again on another drawing. If we go to the next drawing here, we're showing the 3-breaker maintenance bypass with SKRU running in maintenance bypass mode. So again, MIB is open, and BIN can be opened as well, so you can totally de-energize the UPS for any kind of repairs or maintenance while you're running on maintenance bypass. The bad part about a 3-breaker maintenance bypass is you've put all your eggs in one basket. Again, there's a single utility feed for both the UPS input and the maintenance bypass. So if your load is on maintenance bypass, you can't load test the UPS system because there will not be enough capacity from that feeder breaker. And number 2, even if you're on maintenance bypass and you attempt to restart this UPS, and if there's a fault in the UPS or some other fault occurs in the input or bypass, internal bypass circuit of the UPS, you could trip the single feeder breaker to the UPS. So a 3-breaker, if you only have 1 breaker to feed the UPS, a 3-breaker maintenance bypass is certainly better than nothing, but it's not the ideal configuration. We go to the next drawing, and what we're showing is a 2-breaker maintenance bypass with 2 feeders. So if the UPS installation is afforded 2 separate feeder breakers, we would recommend feeding the UPS from 1 feed and feeding the maintenance bypass from a 2nd feed. First drawing showing the UPS online. So the UPS feeder is on, the MIB is on, the MBP is off. Again, before we can go to maintenance bypass, we have to transfer this system to internal bypass. Next drawing shows the 2-breaker with 2 feeds to it and running in the maintenance bypass mode. Under this configuration, we can totally de-energize the UPS, and since it's fed from a separate breaker, if we had to put a load bank or load test this UPS while maintaining your critical load on the maintenance bypass feeder, we can do that. So the shortfall in this configuration is there is a potential for operator error because you have to remember to transfer the system to internal bypass before transferring to maintenance bypass. We go to the next drawing, we go 1 step further. This is a 2-breaker maintenance bypass, but we're providing 3 feeders to the UPS. 1 for the UPS input, 1 for the UPS bypass, and 1 for the maintenance bypass. Drawing shows us online operating with MIB closed and MBP open. Again, no SKRU, so no real protection here, but it does give us even further isolation by having the bypass and the UPS input fed from 2 separate breakers. Next drawing shows that configuration running in internal bypass. So we're running through the internal bypass and out of MIB with MBP off. Now we can operate the maintenance bypass. So by going and doing so, we're going to close MBP, open MIB, and now the next drawing showing us running on the maintenance bypass mode on this system. Again, we can totally de-energize the UPS. We still have the ability to load test this UPS while still maintaining the critical load on the maintenance bypass circuit. This next drawing, we're going 1 step further, and this is the best. 2-breaker maintenance bypass, 3 feeds, and we have the SKRU interlock. This benefit is going to provide us elimination of operator error. We won't be able to go to maintenance bypass until the UPS gives a signal to the SKRU unit that we are in internal bypass. So we bypass the UPS, it allows us to unlock the Kirk key on the maintenance bypass, close it, unlock the MIB, open it. So first drawing again is showing us online. The next drawing shows us we've just transferred the unit to internal bypass, which will now enable the SKR unit. And then the final drawing is showing us successfully running on maintenance bypass and having total isolation capabilities and load testing capabilities of that UPS while still maintaining the load on the maintenance bypass. So to close this out, I would highly recommend you always install an external maintenance bypass on your UPS. What configuration you can do, what your breaker availability will accommodate will dictate what configuration you go with. The less operator error you ever deal with and the more isolation you can provide to your critical load through that maintenance bypass is greatly going to enhance and benefit your facility's operation.